Today we're going to take a look at some of the interactions between angles and how they work. Let's start with something that looks kind of like this. So we have these two intersecting lines. We can number them. 2, go over here, 4. Let's call this 1, call this 3. We can say a lot of different things about these angles. For instance, angle 1 and angle 3 would be what are known as vertical angles. Angle 2 and angle 4 are also vertical angles. Vertical angles are angles that are not adjacent to each other, means they don't share a side, but they do have a common vertex, which we do have that vertex right there in the middle of the intersecting lines. So angle 1 and angle 3, angle 2 and angle 4 would be considered vertical angles. On the flip side of that, we have angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 1 are all what we would call adjacent angles. This means that all the angles share a common side. So angle 1 and angle 2 have this ray here between them. 2 and 3, 3 and 4, 1 and 4 all have a common ray that they share. We could also say that angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 1 are all what we call supplementary angles. Supplementary angles means that all these angles add up to 180 degrees. So we can see here angle 1, angle 2 form a straight line here. 2 and 3, 3 and 4, 4 and 1. All these lines, these pairs, are forming straight lines. The other type of angles that we're going to talk about here, we have to draw a new figure for. And let's draw this here. And this is a right triangle. We're going to label the angles A, B, and C. Angle A and angle B are not equal, but we can say that angle A and angle B are a special type of pair of angles. We would say that they are complementary angles. Complementary angles means that they are a pair of angles that add up to 90 degrees. The reason we know that they are 90 degrees is we come in here, we know this is a right angle, so that's got to be 90 degrees there. And since the interior angles of a triangle are 180, these other two angles have to add up to 90. Now let's take a look at a few example figures and how this all works together. If I were to draw this shape here, and label some of the parts. Let's make this a 90-degree angle. We're going to say this is 50 degrees in here. And we're going to name this angle X, angle Y, and angle Z. If we wanted to find the measurements of angle X, measurement of angle Y, and the measurement of angle Z, we can use a lot of the ideas that we just talked about to find those measurements. The first thing we want to do is find the measurement of angle X here. We can find the measurement of angle x by applying the idea of a triangle having 180 degrees on its interior angles. Well, we know this is 90 degrees here because it's a right angle, and that's 50. And we know that 90 and 50, we add that together, gives us 140 degrees. We subtract that from 180, which is the entire degree measurement of the interior of a triangle. Subtract the 140 from that, and there's our measurement of angle x. Well, we now know that x is 40. Using the idea of vertical angles, which means the opposite angles, we now know that angle z also has to be 40 degrees because vertical angles have equal measurements. They share a common vertex, they don't share sides, and it's where the lines intersect. So angle x has to equal angle z. And since x is 40 degrees, we know that z is also 40 degrees. We can then use the idea of supplementary angles. The two angles on a straight line add up to 180. We could either do z plus y or x plus y, but I know the measurement of angle z plus the measurement of angle y equals 180 degrees because it's supplementary. If I know the measurement of angle z is 40 degrees, I know that 40 degrees plus whatever y equals is 180. If I subtract 40 now, the measurement of angle y has to equal 140 degrees. So I can come over here and say angle y is a 140 degree angle. And so that's one way that we can apply some of the rules that we just got done looking at.